Hello guys, this is Prime Concept. You're welcome once again to my channel. In this video, I want to analyze an aspect of kinematics, which is known as uniformly accelerated motion. Of course, let me quickly remind you that kinematics is an aspect of physics that studies motion without considering the force responsible for that motion. So in kinematics, want to look at how an object moves, but we are not interested in what is causing that object to move. Of course, you know that the agent that makes an object or a particle or a system to move is actually what? Force. So in kinematics, we're interested in everything but force and then momentum. So that is kinematics. What are the parameters of motion, such as velocity, acceleration, distance, displacement, time? These are parameters we are considering in kinematics, but we are not interested in force. So take note of that. But under the kinematics, we'll be looking at uniformly accelerated motion. What is a uniformly accelerated motion? A uniformly accelerated motion is a motion that occurs with constant acceleration. So let me write it. This is a motion with constant acceleration. As a uniformly accelerated motion. This simply means is that in our velocity time graph, remember our velocity time graph is actually a graph of velocity against time. So in our velocity time graph, what it means is that the slope, remember the slope of a velocity time graph would represent acceleration. So it means that for a velocity time graph, the slope is going to be constant. The slope of the velocity time graph will be constant. The slope of a velocity time graph will be constant. So that is what it means. A uniformly accelerated motion with constant what? Acceleration. So that is what this is. Now we want to look at the equations that governs uniformly accelerated motion. These equations are about 5 equations, and we call them equations of motion. So we'll take time to derive these equations one after the other in this video. So in this video, we're going to get about 2-3 of the equations. Then in subsequent videos, we'll derive more of the equations. Then we'll begin to solve problems with the equations. So we want to look at equations of motion, and of course of uniformly accelerated motion. So one of them is, if you recall, when an object travels with varying velocity, say it starts with an initial velocity and then moves on to a final velocity, then the acceleration is going to be given as A, which is V minus U divided by T, right? Now, what we want to quickly do here is to make V the subject formula at the end. We're going to define the parameters. So if you cross multiply, you would have AT equals V minus U. So that I would have that AT, when minus U comes to this side, it becomes plus U, which is equal to V. Now, a better way to write this is to simply say that V is equal to what? U plus AT. So this is one of the equations of motion, which is very popular, that most of the students are familiar with. Now, what is V in this case? V is called final velocity. Then U is called what? Initial velocity. So A is acceleration, and then T is time. T is time. So this is an equation of motion that we should be familiar with. One of them is this. Now, of course, we want to mention average velocity. Now, when a particle, or say a car, travels a long distance, it changes velocity at interval. So at this point, the velocity might be v1, say for example, and the next point, the velocity is v2. The velocity changes at interval, so that when you want to find the average velocity, it's going to be the sum of all those velocity divided by the number of times that velocity changes. But then for a uniformly accelerated motion, we want to assume that the particle only has an initial velocity and a final velocity. So if this is the case, average velocity would be, let me put it this way, average velocity, since our particle under uniformly accelerated motion has just an initial velocity u and a final velocity v, then it means that our average velocity is going to be v plus u divided by what? 2. Of course, so this is our average velocity. Now, knowing our average velocity, we can find a formula for the average distance, or the distance of that the particle travels, or the body or the vehicle travels. So the distance s would be average velocity times what? Time. So that my distance become s, which is average velocity. Average velocity is what? V plus u divided by 2, then multiplied by what now? Time. So this is the second, another equation of motion you need to know, where in this case s is equal to what? Distance. S is equal to distance traveled. So this formula is very important. Very important. Then I want to get one more formula in this video, and then we'll pause for another video so that this does not become too long. Now we've gotten two major formulas in this video. Now we want to get another formula, one more in this video. Now, if you recall, v is u plus at, then s is v plus u over 2 times t. So what I'm going to do, I'm going to put equation 1 into equation 2. So put equation 1 into 2. So that is to say, wherever I see v, in place of this v now, I'll be writing u plus at. So let's do that together. So you have that s is equal to v. Rather than writing v, I would say u plus at, then plus what now? U. V is already u plus at, then plus u, which is this u. Then all divided by 2, then multiplied by what? Time. So if I expand this, I'm going to have that u plus u is 2u plus what now? 80, all divided by what? 2. Then this is being multiplied by time. So what I'm going to do is I'm going to split this. This can be written as 2u over 2 plus 80 over 2. I can split this, then I still have my time outside, so that when I operate on this 2, you can clearly see, can fizzle this. So I'll have s is equal to what now? Is equal to u plus, this can be written as half at, then into t. If I use this time to expand what I have here, I have that s is equal to time times u is ut, then time times time here is going to be plus half at square, because t times t is t square. So this is our equation what? 3. So this is the third equation that we would be needing, right? So we have been able to get 3 equations. One of them is v equals u plus at. The other one is s equals v plus u over 2, then multiplied by time. Then this is the third one. So I'll be stopping here. In my next video, I'm going to show you how we can derive the other 2 equations. So we have 2 more equations. We have 3 already. We have 2 more equations. So we have 5 equations of motion we would be considering. And then I would explain to you very important things that governs problem solving under this. What are those things? These terms or the points that you need to know. If you know this point, trust me, you can solve every problem under uniformly accelerated motion. So do well to stick around and wait for that next video when it will be uploaded, so that you can get the full concept around this. So I'll see you in my next video, where we'll be deriving the 2 more formulas for uniformly accelerated motion and we'll solve problems. Thanks for watching Prime Concepts.